Okay, today we're going to be looking at inverse functions. Notation first. Inverse of f of x is written as f minus 1x. And be aware that similar to the composite functions, we can do one followed by the other. It should get us back to where we started. That's the whole idea. So I can write f minus 1x, which should be the same as f minus 1 f of x equals x. Whatever I put into either one of those should get me back to where I started. Now, it must be one-to-one to have an inverse, so that whatever x value you stick in to get the y value out, I can put that y value back in to get back to where I started. If we have a function like y equals x squared, we can make it one-to-one, as you've seen so far, by limiting the domain and therefore the range. Now, whatever value I stick in for x, I get a y value out. If I put that y value back into the inverse function, I should get back to the x. What it means is that the function its inverse graphically will be reflected in y equals x. We're just going to have a look at the case now. So our example of this is f is such that x goes to x squared minus 2. Now because it's x squared minus 2, it won't be one-to-one unless I only look at part of the curve. So they're specifying in the question, in the example, that x can only lie between x is 1 and x is 3 inclusive. So I've begun to sketch what that looks like here. So it's only this part of the quadratic curve. So I've stuck x is 1 in, 1 minus 2 minus 1. I've stuck x is 3 in, 9 minus 2, 7. So those are the coordinates of the endpoints, as it were, of this part of the curve. And I'm going to try and work out what the inverse function is, sketch the inverse, and show that it should be reflected in y equals x. Now, to find an inverse function, instead of f of x equals, you write y equals x squared minus 2. And you can do the next couple of steps either way around. At some stage or other, we are going to switch the letters x and y over, and then make the other one the subject. And that will lead to our inverse function. In my case, I can write it here, x equals y squared minus 2, y squared equals x plus 2, y equals root x plus 2. Fantastic. So in this case here, pop it to the answer. We pause that.
1.
Right, apologies for the pinging. It's one of you lot sending me work via Twitter, which is fantastic, really. So, we've got this part of the function here. I'm only specifying that it's this part of the curve that we're going to do the inverse of. And so, what happens is this. When x is 1, y is minus 1, means when I put minus 1 into the inverse function as the x value, I get y is 1. So, it starts off, in this case, at that point there. And similarly, when x is 3, y is 7 to the original function, when I put 7 into this one, add 2 and square root it, so as an x value of 7, I get a y value of 3. What this curve looks like, hopefully, is a little bit like this here. So it does that sort of thing, and it's reflected in y equals x there. So that's my original curve, that's my inverse function there, and they are reflected in y equals x. Now, let's look at something else that's relevant as well, the domain and range. What happens for the domain for the original one, which was minus 1 less than or equal to x less than or equal to 3, and the range, minus 1 to 7, and don't forget it's f of x less than or equal to 7. What happens for these here, in this case, the x value has gone from minus 1 to 7, so it wasn't minus 1 there, it was plus 1, wasn't it? From minus 1 to 7. So I will put for the inverse function an x value of minus 1 for there, up to and including 7. But the y value is only going from 1 to 3. So for the range of it, after minus 1, we get this. So notice that the domain of 1 is the range of the other. And obviously the other difference is, for the domain it has to be x's from one to another, and for the range it's the function from one to the other. So domain of f is 1 to 3, the range of the function is from 1 to 3. The range of the original function was from minus 1 to 7, the domain of the inverse is from -1 to 7. Okay, let's have a look at some of the sort of things you might be asked to do then. So, we've got function hx equals 3 over 2x minus 1. X is a real number, x is bigger than a half, so it's only part of my part of my curve there. I'll be asked for a few things. I'm going to be asked to find what the inverse function is. Okay, so as we said before, there's my question. Let y equal 3 over 2x minus 1, and then switch the letters over. I would generally do it first. X equals 3 over 2y minus 1. Do a quick switcheroo. 2y minus 1 equals 3 over x. 2y equals 3 over x plus 1, or 3 plus x all over x, and then y equals 3 plus x all over 2x. Okay. The domain of the inverse function is quite straightforward. It's the range of the original function itself. The range of the inverse is the domain of the original function itself. Think about what sort of curve it is. It would normally have an asymptote at x as a half, and so at x is bigger than a half, we've got that function there. So in this case here, the range of the original function is that y is bigger than 0, because it goes up to infinity. So the domain of this is that x is bigger than 0, and the range of this one is that h, isn't it? H to the minus 1x is any old value at all, as long as it is, h to the minus 1x is bigger than a half. Okay? So notice that the domain of one is the range of the other. To work out the domain of the inverse, I need the range of the original function. Second example, same sort of idea, slightly harder one to find the inverse function of. So that's the question. I've got to try and find the inverse function here. So as before, let y equal the function. And switch the letters over. X equals 2y over y plus 1. The difficulty is going to be here that y appears twice. So cross multiply xy plus x equals 2y. Get everything with y on one side. So x equals 2y minus xy, or y times 2 minus x, and then cross divide to get y, which is my inverse function now, equals x over 2 minus x. I should really write that as f to the minus 1. I should have done that for that one before, and written that as h to the minus 1x there. And there's my function there. It's always harder to find inverse functions when the letter appears twice in it, as we'll see in other examples later on. Two more to look at. Got scratched all over the place here. This one, f(x) equals e to the 2x minus 3, x is any old real number. I need to find the inverse function and solve f minus 1x equals 0. So let's start off by writing y equals e to the 2x minus 3. Switch the letters over. E to the 2y minus 3, and let's try and make y the subject. E to the 2y equals x plus 3. Take logs, and then halve it. Y equals a half ln x plus 3, or I could write it as ln of root x plus 3. And that's now my inverse function, f to the minus 1x. For the next part, if I want to solve it equal to 0, when is log 0? Log of 1 is 0. So when root x plus 3 equals 1, x plus 3 equals 1, x equals 1 minus 3, which is minus 2. Okay, so in that case there, that's my one solution to that one there. Lastly, I've got a quadratic. fx equals x squared minus 8x plus 12. X is bigger than or equal to 4. So as I said before, by cutting down the domain, we make it 1 to 1. I'm asked for the range of it, and asked for the inverse function. To help me do both of these, and sketch it. Now we do both of these. I need to simplify this. I can't be dealing with finding an inverse function when I've got an x there and an x there. It's why we complete the square. I can solve equations when I'm completing the square. I can undo it, and that's how we solve equations. So what I'm going to do with the function is complete the square. And write x minus 4 all squared minus 16 plus 12, which is x minus 4 all squared minus 4. What it tells me is, as long as x is bigger than or equal to 4, no matter what I stick in there, if x is equal to 4, then that makes y equal to minus 4. And then anything else has to be bigger than minus 4. So y, the range of it, is bigger than or equal to minus 4. That's my range. And I can use this to then undo it. I can say I've got y equals this, switch the letters over, x equals y minus 4 all squared minus 4, make y the subject. I couldn't have done it there in that form. Completing the square helps me, so I can then say y minus 4 all squared equals x plus 4, root it, don't forget I don't have to do plus or minus because I'm only doing the part of it, so y minus 4 equals that, y equals 4 plus the square root of x plus 4. That's my inverse function, that's f to the minus 1 of x. Okay, and then I'm asked to sketch it, so let's see what I can do. I would normally have, it will bottom out at x equal to 4, just like that, and y is minus 4. Just checking where we'll go through like this. So my original function is going to do that idea there, so it's going to be from 4 and minus 4. And what's going to happen there, it's going to start off somewhere over here, and y is 4 and x is minus 4, somewhere like this, and the inverse function is going to look like that, and it can be mirrored in y equals x. Okay, so when you've got a point on the original function, basically switch over the x and y's. So in this case, x is 4, y is minus 4. This one, x is minus 4, y is 4, and then plot it. Same for all the other ones. And notice there, they both can be mirrored in that y equals x, and that's how they look as a sketch.